Hi, I'm Tom Mays from NodeWeaver, and I'm joined in the room by our CTO, Lorenzo Falaschini, and via Zoom by our CEO, Carlo De Fara. NodeWeaver is a software-defined edge operating platform that enables the nonstop operation of fleets of fully autonomous nano clouds that are zero-touch deployable at any edge location and run on any hardware. So in our last segment, our heroes wrapped up the deployment of hundreds of new edge sites around the world, and they were able to finish it on time and under budget. The focus of this segment now is going to be on the long-term management and maintenance of the fleet of edge clusters. So we'd like to start by showing you how easy it is to add a node to an existing cluster. So in the previous segment, we mentioned that NodeWeaver is hardware agnostic, and I think Bart, you asked the question earlier about, somebody asked the question about whether we can intermix different servers within the same cluster, and that's also another big advantage. Certainly on initial deployment, greenfield deployment, we expect that people are going to put out homogeneous systems for the first cut, but being able to intermix different servers solves a lot of problems. Number one, your spares pool you don't have to have a giant spares pool of identical systems. You can refresh it as you need it with whatever's latest and greatest and most efficient at the time. You can start with, Bart, you asked about a single node cluster. You can start with a single node cluster and add additional nodes, or you can start with small servers and add larger ones as the value of your edge deployment grows over time. You can also do rolling refreshes in the future, which is another big challenge. Like, okay, great, I got this out here, but when I need to refresh this hardware, do I have to take downtime and send somebody out there? And the answer is no. You can just install the new servers, join them to the cluster, and live migrate everything with no downtime over to the new hardware. So I'm going to ask Lorenzo at this point if he would come. And what we're going to do is we have, in the previous segment, we deployed on this node, which is an Intel Core processor, and he's going to add an Atom-based processor to this cluster.
So, as you asked, Brian, we're going to reuse the same USB stick, okay? So, I'm going to be plugging just USB stick. Again, console is needed just for the web audience to catch this, and for the picture-in-picture. And a little bit of networking. Let me bring out the picture-in-picture so the web audience can attend this.
So the process for this is exactly the same as for the first node. It's going to boot off of the USB installer. It's going to install on the internal hard drive of the server, reboot, come up with the cluster configuration that's stored on the USB stick. And at that point, it will automatically find and join the existing cluster. And then it will start immediately, and again, automatically replicating and leveling storage. If this is if this cluster, for instance, already had 4 or 5 nodes, you add another node, it's just going to re-level that for you automatically across the new resources. And also redistributing resources to load balancing all the workloads across the new available resources. When we install on a new server, we interrogate the underlying hardware, and we know, looking at the probes that Carlos showed in one of the earlier segments, we know what the hardware is capable of. So we interrogate the hardware, we know what's available, and that way we can appropriately load balance across even very dissimilar systems.
Sorry, since Gina is stepped away for a second, I'm going to just gift her with an additional node, which again is heterogeneous. He had deployed a NUC system, and we are going to have a Lenovo. But they are both Intel Core based. This is like 13th generation, this is 8th.
You just said you can load balance across it. So are you on the fly doing load balancing? The system itself is figuring out where to do that. You can set some parameters and
it's just going to migrate the workloads themselves over across the different nodes in the cluster.
I'm getting an idea of what you're doing with your virtualization and those pieces of what you've got built in.
Yes, exactly. Yeah, live migration and then automatic load balancing is part of.
Now that's for the workloads or also the data? Because initially I have a VM, let's say, or a container running here.
Yep.
If you're going to load balance it now to another system, where is the data? The copy of the data, is it here or will it be moved there as well?
It can move it automatically, but remember that we typically keep 2 copies of the data in the system. So it's always going to try to maintain locality of the workload and the data. If it moves things around, it'll...
Yes, it optimizes placement where the most, where those chunks Carlo was talking before, which are the bits of data that compose your virtual images, are going to be moved. If you have multi-node system, it's going to be moved nearby where the hypervisor is using it or the system is using it. The replica is transparent and synchronous, and CRC, every single write is as CRC check. So you're sure that when you have a replica, okay, then you're sure that this is going to be down all the way to the DD scan. That's going to be saved. When you change, pretend you start something which is on rotational media, you want to change it later on to be faster because you need to move it to production where you just hit the IO limit for that. You just go and change the simple attribute for the image involved from goal equals HDD2, which means copy on 2 servers on HDD media to NVMe2, and it's going to live migrate while the VM is running. The new writes are going to be immediately written on the NVMe, and all the pre-gressed storage is going to be migrated live, and we handle all the QoS and the stuff to make it even.
So at least have control on it, because let's say I have a box here now with an SSD or NVMe. I added a second box with spinning media, and then it's going to start over. The performance will be lower at that moment.
Yes, because it goes at the, it will be limited if you have a single rotational media and a single NVMe on the other is going to be at the, it's going to be affected by the speed of the rotational media, because you want, and we first preserve as our top priority is resiliency. So we first want Replica 2, then performance.
Yeah, there's a reason it's called goal.
Yes.
Right? So we're going to prioritize getting you a second copy. It's going to make good decisions on its own, which is kind of the whole autonomous nature of this, right? I don't need to make the decision about whether I need I need 2 copies. And if it can be fast, I'll make it fast. But if I can't, I'm still going to give you 2 copies. Yeah.
And it sounds like that's all policy-based.
No, it's all determined automatically. Yeah, it's not policy-based, though. No.
Oh, okay.
Right.
Yeah.
You can select anytime,
right,
image per image, VM per VM, workload per workload, where and how the number of replicas and this type of media where it goes. We have also special goals like auto-archiving, so that it writes an SSD2, for example, and after 24 hours, the data is moved to HD. For example, if you have write now and read later, maybe, so that's kind of workload that fits that goal.
Okay.
If you have a DBMS to run there, NVMe2. Yeah, that's it.
Okay.
As easy as
you just have define
value.
Now I have one more question about that USB stick. So the configuration of the cluster is on the USB stick, because you deployed the first node with that stick. Now you put it in the second one.
Correct.
So he knows indeed that, oh, there is already a node, which I assume at that moment, the first node needs to be active and at least on the same network.
Yes.
So that it can find that other in the cluster. Actually.
Exactly.
That's a requirement. That's on the same network.
Exactly.
Because
same layer 2
network.
network.
We'll have a split brain.
Correct. Exactly. Yep. Exactly. Same layer 2 network, and then they'll find each other and join together automatically.
We have split brain prevention and also auto split brain remediation in case. So if you, on a purpose, you separate the 2 nodes in 2 VLANs and then you rejoin back, it will figure out the best thing to do.
Because that's the interesting question from Brian that is on its way. But for me, myself as well, is how is this possible that if I have a split brain, I have 2 boxes or nodes, systems who have workloads running. So I have data that is changed, and then they find each other back again. Who will win with the changed data?
Yeah, Carlo, do you want to take that one?
First of all, we do have a set of safety mechanisms. One is called the canary IP, which is used to identify whether the network is working properly or not. And we have what we call external probes for that. But let's say that you create a split brain and you design it so that you will have a split brain, because you really need to work hard to make it. In this case, we have a system that is called version vectors. Basically, everything that happens on the distributed file system is transactional. And you have a transaction and you have a hash that tells which cluster is doing this transaction. So what happens if you have a split brain? You get two master nodes. The node that is elected as a new master node will get a new hash. And basically, all the metadata of that will have a new root, which does have a different hash. So when you rejoin the two things together, the system will identify this as a competing master and will start to replay all the transaction up to the point where the split brain happened. And at that point, you have a policy that decides what you want to keep. And the system will start to remediate the storage of both clusters and will rejoin things together. So you can say, for example, oh no, something important happened on both nodes. I want to preserve all the data. And it will create a new copy of that and will join back to the other cluster. Or I want just to have the oldest node to win, and the system will remediate on its own. It's policy-based and it's automatic.
Okay. Thanks. Makes sense.
So at this point, the second node that we installed has already joined the cluster. Lorenzo's going to kind of show this quickly.
Now, this has gone like the first node through all the process. Leave the console there. We don't need it anymore. And now you see that the VMs are being booted right now on the other host. So
we had some VMs that were on hold pending for the second node to come up, and now they're automatically started.
We had anti-affinity set on them. And we just go here and we check under infrastructure. We're going to see that a new node joined. And can you see it's already overloaded, poor Atom, it's 2 cores only, but it's doing his work, okay? And it's keeping up the good stuff like the replicas. So we are already, so this is not a lot of data in here, but it's already at goal 2. So both servers have a copy in this 2 nodes cluster. It's like, now it's behaving like a RAID 1. But it's a RAIN, redundant array of independent nodes. So anytime we kill the other will take place.
Yeah, and the reason why it happened to try to start everything is that because we had anti-affinity, so we asked it to run everything as far as possible, which means do whatever you need to respect my wishes, which even means overload it because it's what it has to do.
Okay. If you want, I will fly over this.
Yeah, one of the next things that the team needed to solve is you want visibility into the health of your entire fleet, and not just of the NodeWeaver clusters, but all the way down to the VMs that are running and down to the application level as well. And so Lorenzo is going to walk us through an example of our fleet monitoring tool, which is included as well, called Edge Insight.
Well, I have to catch up a bit of time because we are up. We are a bit late, so sorry if I keep this very quick. So Edge Insight is a layer on top of NodeWeaver that is can be delivered on any cluster. So monitoring is a key part of an edge deployment. You really don't want to go check cluster by cluster what's going on. You're going to just be driving nuts. So for this reason, we provide a monitoring which is integrated with the system. And as you can see from this slide, you can also have geopositioning, so you can have a real-time update or where the cluster is. Think a ship will move, so you also have that data at a glance. We support distributed monitoring, so what you see is the topology of a distributed monitoring site deployment. So each purple dot is a single cluster, so it has there is a VM, as everything is a VM for us that is running on top of the cluster, doing the monitoring locally, monitoring both the hardware, the cluster, and the workloads on top. If these are internet connected, they can be joined into a distributed monitoring view like this, so you can get an eagle sight of what you deployed. And as you see, it's very easy to spot out which VM carries a problem or if there is something with a cluster, site per site. On top of that, you can drill into detail. So every one of these little dots there, you can click in and you can see service by service. It has also log watch capabilities. So you can filter your logs and raise an alert for you on a scale. more on top of that, you get time series. So it's very efficient in storing up to 400 days of historical data. Of course, you will have a higher degree of details in the last 4 hours, a bit less in 25 than in the week, et cetera, et cetera. We keep shredding the density of the data to avoid over-consuming CPU because, I mean, come on, atoms, and also storage because it's precious.
Can you get to that data? Can you extract out or query the time series database?
This is all. Everything in NodeWeaver is API usable and configurable. So you're going to have your REST API to you can exfiltrate this, put it to your whatever you have. I mean, many have their own monitoring system. We can just give you the data in a usable form. And that's it. So sorry for jumping in so quick. If you have any questions, of course, I'm here. But
one last thing I'll just add real quickly is that this can also monitor anything that you have at the site, even if it's not running inside NodeWeaver. So it can monitor external things. As long as they're network connected and SNMP enabled, you can monitor switches, routers, HVAC, whatever else is at that site as well. So it's a complete system because a lot of the sites that we deploy into, NodeWeaver is the only thing that's at that site. So you still need to make sure everything else is operational.
So semi-hypothetical situation.
Yeah.
What happens if you drop this into an IPv6 only network?
into NAND?
IPv6 only.
Yes, I mean, the VMs can have a mix of IPv4, IPv6.
So if there's no IPv4 anywhere on the network, everything will
IPv4
still work?
is used internally, but it uses a reserved class, so it's not going to interfere with anything else.
But it'll still be able to talk out to the cloud over the IPv6 and all of that?
Yeah.
Okay, good.
And it's one other thing just to quickly mention, it also manages auto-scaling and complex services. So it can keep track of hierarchy of services that are deployed, that are erogated by multiple VMs. So you have master that should be booted before, and then it takes care of checking the master is booted and then boots the worker. And you can set elasticity policy for workers. So if the worker gets over 60% of CPU usage, it will spawn others. And if it gets lower, it just releases resources to the cluster. So just to mention that, we didn't have time to, because the time is really strict. But
yeah. So the last thing we wanted to show you is more of a long-term move, add, change capability, because of course, over time, customers are going to want to add new applications or change something that's configured out in the field. One of the great things is that you don't have to go cluster by cluster and manually make those changes. You can use the same Bootstrap system that we used to deploy all of the virtual networks and VMs when we did the initial deployment to do small changes to those systems. Exactly the same system, same construct. So we're going to show that just real briefly. What we're going to show is a Bootstrap package that we use for almost all of our customers. And what this one does is deploy our snapshot-based service, or our service VMs that create snapshot-based backups.
Yeah, this is a simple string, as you see. It's nothing more than a base64 encoded command. So I just copy over the Bootstrap script that created our original VMs, and I modify that parameter, and it's gonna be handled by the system. It will recognize the change in it, and it's gonna apply a new Bootstrap VM that it's gonna be deploying a number of things like creating a new user and creating an ACL for that user, which is able to access only the images to back them up, and download a virtual appliance from the marketplace, which is the time turner. And it's going to be spawning 3 time turners, and those are going to be applying 3 different snapshot policies with different retentions. So, and this is all done by, now I've copied and pasted it to a single cluster. This can be, of course, pasted to a system that can deliver it for a region or for your worldwide deployment. I say, I want this running now on all clusters or on just a subset of them.
Can you talk briefly about data protection? I noticed on one of the original slides it said something about data protection services or something to that. What are your customers doing for backups, and how are they protecting data on their edges when they're running NodeWeaver?
Yeah, perfect question. So number one is that we are replicating data, multiple copies across different disks and different systems in the cluster, so there's redundancy.
Yep.
If you lose a disk, whatever was on that disk automatically gets recreated from the surviving copy somewhere else in the cluster. If you lose an entire server, it will automatically recreate from the surviving copy somewhere else in the cluster. Now, that's just kind of like low-level data protection, but then beyond that is snapshots. Snapshots come for free. They're pointer-based, so they're very fast and very efficient, zero-space snapshots. Those snapshots can go locally. They can also be sent to an offsite or off-system location.
You just manage that to external data store. So you can create a virtual data store inside of the DFS, which is holding your snapshots, and so you can recover 1 terabyte image in seconds. Or you can, I don't know, attach whatever, an S3 bucket. You can attach an NFS or CAFS, which is laying down out there, and you're going to be sending the same time, same machine, which is the time turner, can take a local snapshot and then take that still copy out to the external.
And so they're full snapshots. There's no incremental chain or anything.
No,
like that.
it's full snapshots. You can export a local snapshot data store and run and read that on top in a VM to use whatever local dedupe thing that you want. A typical approach is to have a little, can be, I mean, whatever is locally available, you can set the copy there and then replicate that offline if the site is provided with external storage. Otherwise, I mean, there are multiple ways.
But local snapshots are pointer-based, zero-space snapshots. Yeah, it's only when we send off remote.
Naturally, they duplicate it. Because they just point the new metadata and they only keep the changes.
Yeah.
Okay, so
Right.
they don't even have they don't have to merge each other if you delete one. So it's very quick.
So I did want to give Carlo a moment to talk about security because, oh, thank you. Because, as we've talked about earlier, these systems are not deployed in, data centers with biometric security and armed guards. A lot of times they're deployed in very remote locations that, are exposed, and this represents a big threat surface. So I'd like Carlo to kind of talk through what we do for platform level security in NodeWeaver.
Yeah, thank you. The key point is that security is a continuous property because you cannot be secure just in the beginning or just in some moment in time. You need to be secure always because otherwise you basically risk that something happened while you was not. So we designed NodeWeaver with the key concept that security should be one of the key elements along with the simplicity and lightness that decide what we have to implement and how we implement it. So we have tried to talk about the multiple ways an attack can be done, what is specific for the edge, like, for example, the lack of physical security and so on. So we have basically clustered the security as a continuous property over 4 different axes. The first one is platform integrity, of course. The operating system is a hardened Linux, as we said before. It's actually the entire system is encrypted. The firmware is tamper-proof. Basically, if you try to modify it, it will simply disable itself and will check everything at runtime. So if you modify something, we identify it and we shut everything down. We support TPMs. We have support for vaults. Everything for the management traffic is encrypted within the node itself and across nodes. And every node does have an integrated denial of service protection and firewall. So we design everything so that the platform is always secure from the beginning. But then we have workload integrity. That's one of the reasons why we use an hypervisor for everything, including containers, because this way we can provide a higher barrier between different workloads. Because sometimes you have different teams working on the same system, so you are not always able to identify who is doing what. The other thing that we do is strong workload installation in terms of resources. We want to make sure that one workload is not able to take all the time or CPU or memory from the others. So we have strong partitioning on the resource side. We have soft and hard barriers for resources like CPU, memory, I/O. And we have a set of, let's say, extensions like pinning that allow us to reserve hard part of the system, And we have a special real-time mode that allows us to provide low latency guarantees on everything. We have updates, small, incremental, and encrypted, with no need for reboots, so the system remains live. And we can also update air-gap systems. We simply provide you the firmware, the encrypted updates, and there's a special Samba share inside of NodeWeaver that is designed to upload that. And the last part, which is very important, is auditability. We have full logging and auditing of everything. We can also enable API tracing. So we are able to track everything that happens on the system, be it on the web side, on the setup side, on things like Terraform, Ansible, or Puppet, or Salt, or whatever. Everything can be traced, and basically it allows full visibility on what a user asks the system to do. So we are able at all time to identify who asked for a change, what that change was, and so on. That's why everything that runs on NodeWeaver, including things like the time turners, the backup services, and everything else, actually is a VM that talks through the API as everyone else. There is no privileged system. Everything is as modular as possible.
And certainly we invite anyone who might be interested in talking to us about your edge projects. Please contact us at nodeweaver.io, and we will look forward to working with you.